Hello everybody! So this is only my second time using this app, so bear with me, but I'm just going to go a little bit through 6.8 and I'm going to go over 6.9 examples, as many as I can. I'm going to try and get this done in about 25 minutes so you're not watching too long of a video. So here we go. We'll start with number 9 in 6.8. We did 7 and 8, I believe. So 9. This is called solve using factoring. All right, so on each side we have 3 tan squared of u minus square root of 3 tan of u equals 0. And we are in the third quadrant. Ooh, let me get my pen. Third quadrant. Okay, so we can treat this like we would an x problem. So if we had 3x squared minus square root of 3x, we would solve this by factoring out x. So let's do it. So x, we're left with 3x minus square root of 3 equals 0. And then we would set each of these equal to 0 and solve. Except we don't have x anymore. We would have to substitute. So I'm going to move this over a bit and then put what I need in there. So we would get tan of u. And we would have 3 tan of u minus square root of 3. And we're saying this equal to 0, so we can do it. So where does tan of u equal 0? Tan of u equals 0 when u is, in this case, we're in the third quadrant, so pi. Because we're looking for where sine is 0. And sine is 0 at pi. 3 tan of u equals, so we have to set this equal to 0 as well. So 3 tan of u minus square root of 3 equals 0. We solve. 3 tan of u equals square root of 3. Tan of u equals square root of 3 over 3. So u is going to equal, since we're in the third quadrant, 7 pi over 6. There we go. So we have two solutions. Both are in the third quadrant. Good to go. So we can make that look a little prettier and put it here. There we go. There's number 9. Number 10, we have sine of x secant of x plus 2 square root of 2 sine of x equals square root of 2 sine of x. So I would see this as 1 times square root of 2 sine of x, and I would subtract that over first. So I would get sine of x times secant of x plus 2 square root of 2 sine of x minus 1 square root of 2 sine of x is just 1 square root of 2 sine of x. Or what happened here? Oh boy. So that would give me square root of 2 sine of x. And this is all going to be equal to 0 now. All right, so now what can I do? Similar to the last problem, I have a sine of x on each side of the addition. So I can factor sine of x out. So sine of x, and then we have this side of the addition divided by sine of x is just going to give us secant of x. And then this side of the x, sine of the plus, divided by sine of x is just going to give us square root of 2. So this is going to equal 0. Okay, so there we go. So we can set each equal to 0. Change color. This is tough to see. Let's go blue. Sine of x equals 0. This is going to be secant of x equals negative square root of 2. And we just solve. We are in either the first or second quadrant. So where's sine of x equal to 0 in the first or second quadrant? At x equals 0 or pi. And for secant, I don't usually like to leave it with secant. I change it to cosine. So cosine would be cosine of x equals negative 1 over square root of 2, which is equal to negative square root of 2 over 2, which we know pretty easily as x equals 3 pi over 4. So there we go, 3 solutions. X equals 0, 3 pi over 4, and pi. Done. Next, 11 and 12. Should we do all these? Yeah, let's just do them all. 11 and 12. Here we go. So we have cosecant theta plus 5 equals 7. So let's get it all onto one side. So we get cosecant. Whoa, that doesn't go there. Cosecant squared theta. Get the 7 over and the cosecant. So we will have plus cosecant theta. And then the 5 minus 7 will be minus 2. And that's all going to be equal to 0. I just brought this over here. Both of those over there. All right, so again, if you can't see this pattern and it freaks you out with the trig, just change it to x squared plus x minus 2. That's fine. So we get x squared plus x minus 2 equals 0. That's easy. Right? Since we are in trig mode, let's get this to the left a bit. Boop. Change it to cosecant now. There we go. So we get cosecant of theta plus 2 times cosecant of theta minus 1 equals 0. Split it up and solve. Cosecant of theta plus 2 equals 0. Cosecant of theta equals negative 2. I change it to sine. Sine of theta is the reciprocal of negative 2, so negative 1/2. This one, same thing. Cosecant of theta equals 1. Sine of theta equals, reciprocal of 1 is 1. Nice. So theta equals, what quadrant are we in here? Fourth quadrant. So in the fourth quadrant, we get 11 pi over 6. And can sine equal 1 in the fourth quadrant? No. So empty set. Boop. Therefore, our answer is thus. And there we go. So 12, same thing. I think you got the hang of that. Similar, if you don't have the hang of that, that would be like 2x squared plus 3x minus 2 equals 0. And then you would solve like you would a regular quadratic function. Okay, number 13. Oh boy, it's a little bit trickier, so let's do this. All right, get it all onto one side. Secant to the 4th power x. Okay, we're going to be subtracting a secant of x squared from the right. So we get a negative 5 secant squared x. And then we're adding a 1. There we go. So if this power is half of this power and we have a constant over here, we're good to go. We can use regular factoring. So if you're confused, you could change it to x 4th minus 5x squared plus 4. Split that up into x squared minus 4, x squared minus 1, and solve. However, got to change it back. So let's do it. Flip this side. And here we go. So we will take this and change it back to secant. So secant squared x minus 4. Secant squared x minus 1. All that equal to 0. So let's solve for both. Secant squared x equals 4. Secant of x equals plus or minus 2. Which means cosine of x equals plus or minus 1/2. Same thing. Secant squared x equals 1. Secant of x equals plus or minus 1. And the inverse of that is going to be the same. All right, quadrant's important for this. So quadrant is going to be 3rd and 4th. Nice. So where does cosine of x equal plus or minus 1/2? That's going to be, let's do positive 1/2 first. That's going to be 5 pi over 3. And then negative is going to be 4 pi over 3. And there's going to be 1, and x is at 0. Wait. And cosine is going to be 1, 0. Yes, that'd be true, but it's not in the domain, but 2 pi is in the domain, which is the same thing, so we can use 2 pi. And at negative 1, it would be pi, which is in the domain. So our answers are going to be all those. Let's put them in ascending order. Oops, forgot pi. And 2 pi. There we go. Nice job. All right, number 14. Ooh, tricky. So if we had same thing, x cubed plus x squared minus 3x minus 3 equals 0. How would we normally do this? I would use grouping. Point, get x squared, x plus 1. Then I'd factor out a 3? Negative 3. So that would be plus 3. And then we get x plus 1. There we go. So we can break that up. Wait a second. Oops. Screw that up. Let's go back. Whoop, 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 whoop. We would get x cubed plus x squared minus 3x minus 3 equals 0. So when we factor that, we get grouping. Yeah, I just grouped wrong. So x squared, x plus 1, and then we factor out negative 3, and then we get x plus 1. Both become positive. There we go. And then it would be x squared minus 3, x plus 1 equals 0. Very nice. Except we don't want x anymore. We want to switch it to tan of y. So let's make that smaller. Move it to the side. Okay, back. Now we change the x's to tan. We get tangent squared y minus 3 times tangent y plus 1 equals 0. And let's solve. We get tan of y equals plus or minus square root of 3. And this one, we get tan of y equals negative 1. So y, since it's in either the first or second quadrant, is going to be, only way it can be negatives is second quadrant, so that's going to be 3 pi over 4. This one, we can get two values, pi over 3 and 2 pi over 3, since it could be plus or minus. So we have 3 values total, pi over 3, 2 pi over 3, and 3 pi over 4. And we are done. Done with that one. So that is using factoring to solve. Now we're going to use basic identities. Here we go. I'm just going to do the, can I do all of these? Do I have time? No, I'm just going to do the odd. There we go. So basic identities. So we can't have cosine of x and sine squared of x. So let's change one of those to cosine or the other to sine. Since cosine of x isn't squared, we're going to have to change sine squared x. So this is going to give us cosine of x minus 1 equals 1 minus cosine squared x. If you don't know how I did that, you got to go back and study your trig identities. All right, so let's get it all on one side. We get cosine squared of x plus cosine of x minus 2 equals 0. Solve by factoring cosine of x plus 2, cosine of x minus 1. Not bad. So cosine of x equals negative 2 and cosine of x equals 1. Is it possible for cosine of x to equal negative 2 if we don't have an amplitude here? Nope. So empty set. Is it possible to have cosine of x equal 1? It is. At 0, and then 2 pi, and then 4 pi, and then 6 pi. Since we're going from negative infinity to infinity, we have to include this, where n is an element of integers. N can't be a real number here. It's got to be more specifically an integer. And there we go. There's our answer. Okay, number 17. Wow, we're already on 17. Here we go. So, oh man, we have tangent and sine. How do we get this to work here? Okay. What we can do is change tan to sine over cosine. So we get 3 sine of A. Oh, I gotta write that nicer. Let's change colors too. Let's go purple. 3 sine of A over cosine of A minus 2 square roots of 3 sine of A equals 0. All right, so remember, this can be written the same thing as 3 times sine of A times 1 over cosine of A minus sine of A equals 0. So now we have a sine of A on both sides of the subtraction. So we can factor that out. So if we do, we get sine of A out, and then this side, the left side divided by sine of A is going to be 3 secant of A. And then on the right side, we're just going to have 2 square roots of 3. And we can solve for that. So we get sine of A equals 0. So A is going to be equal to so this is third and fourth quadrant, so that can be pi or 2 pi. It can also be 0, but 0 is not in that quadrant. All right, so here we go. 3 secant of A equals 2 square roots of 3. Secant of A equals 2 square roots of 3 over 3. I would change that to cosine, which is going to equal 3 over 2 square roots of 3, which is going to equal 3 square roots of 3 over 6, which equals square root of 3 over 2. Ah, much easier. So I'm going to make this a little bit smaller so you can fit it here. Oops, I missed a piece. Or just move to the side. And I will erase a 0. Just put it back. Okay, so we are trying to do cosine of A. We already have where sine of A equals 0. Now we got to do cosine. So where's cosine of A equals square root of 3 over 2? And it has to be in the third or fourth quadrant. So for it to be positive, a cosine has to be in the fourth quadrant. So A must equal 11 pi over 6. So A can equal pi. Oops, didn't mean to underline that. A can equal pi, 11 pi over 6, and 2 pi. And there we go. There's 17. Okay, 19. Oh boy. So we got difference of angles and difference of angles again. So since it's saying solving using sum and difference identities, I assume we have to expand it. So we get sine of pi over 6 cosine of beta minus cosine, I like it the other way. Sine of beta cosine of pi over 6. All that minus, now we're going to do the cosine side. So I should maybe change colors. Let's do green. Green's not easy to see. Let's do blue. That's this side. So that's going to be cosine of pi over 3 cosine of beta plus sine of pi over 3 sine of beta, all equaling square root of 6 over 2. All right, let's simplify this. Sine of pi over 6 is 1/2 cosine of b minus sine of b. Cosine of pi over 6 is square root of 3 over 2. All that minus cosine of pi over 3 is 1/2 cosine of b. I see something there. Plus sine of pi over 3, which is square root of 3 over 2 sine of b. All that equaling square root of 6 over 2. All right, so we have 1/2 cosine of b minus 1/2 cosine of b. That is going to cancel out. We get negative sine of b. Let's actually write this a little bit differently so you can see it a little bit better. We get square root of 3 over 2 sine of b. So we have negative square root of 3 over 2 sine of b minus square root of 3 over 2 sine of b. So what does that give us? So a negative 1 times, plus 1 times, gives us what? I wonder. Minus, so it's a minus a plus, so that's minus. So we get negative 2 square roots of 3 over 2 sine of b equals square root of 6 over 2. 2's cancel out. So we get negative square root of 3 sine of b equals square root of 6 over 2. Let's bring this over here. And then we get sine of b equals negative square root of 6 over 2 square roots of 3, which equals negative square root of 2 over 2. 18, 9, 3. Let's see here. Yeah, should be good. So where does that equal negative square root of 2 over 2? When beta is 5 pi over 4 and 7 pi over 4, because it is in the any quadrant. There we go. Since sine has to be negative in the third or fourth, that's why we use the third or fourth quadrant ones. There we go, 19. There is sum difference identity example. Here is a double angle identity example. So we have sine of 2u plus 4 cosine of u equals 3 cosine of u. Here we go. So we obviously, since it's double angle identities, we're going to be expanding sine of 2u. So that will give us 2, what happened there? 2 sine of u cosine of u. And let's get the 3 cosine u over to the other side. So we get plus cosine of u equals 0. 4 cosine of u minus 3 cosine of u equals 1 cosine of u. All right, and then we have a cosine of u on both sides of the addition. So we can factor it out. That will give us cosine of u. 2 sine of u cosine of u divided by cosine of u is just 2 sine of u. Cosine of u on the right side divided by cosine of u is just 1. And then we can solve. Where does cosine of u equal 0? Where does 2 sine of u plus 1 equal 0? Where's cosine of u equal 0? First we got to check what quadrants. Any quadrant. Nice. So when u is pi over 2 and 3 pi over 2. When does sine of u equal negative 1/2? Good question. When u is 7 pi over 6 and 11 pi over 6. This is better with an audience. Ugh. All right, anyway, let's put all these together. We get pi over 2, 3 pi over 2. I'm not going to even do it in descending order anymore. 11 pi over 6. There we go. Done. 21, done. Now half angle, and then product of sum, and we are finished. Half angle, here we go. So, yeah, obviously we got to expand the half angle one. But, oh man, it's going to have a square root in it, and it's going to be a mess. Maybe we can get rid of that square root by just squaring both sides. Let's do that. Yeah, squaring both sides. If we do it to one side, we got to do it to the other. So this side, we're going to get cosine squared x plus 4 cosine x plus 4 equals, and then normally we would have 1 minus cosine x over 2 plus or minus the square root. However, we are squaring it now, so we're just going to get 1 minus cosine of x over 2. Makes things a little bit easier, so we can multiply both sides by 2. We get 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine x. Get everything on one side, set it equal to 0. So we add cosine x and subtract 1. So we get 2 cosine squared x plus 9 cosine x plus 7 equals 0. Oh boy. Now we just use regular factoring like we have. If you're a little confused, we can switch it back to x. So we get 2x squared plus 9x plus 7. I take out the 2 and multiply it by the constant and get x squared plus 9x plus 14. Carry the 2. Factor that now, we get x plus 7, x plus 2, and now I divide, ooh, that's supposed to be 2. Then I divide by 2, and I get, if you can't simplify anymore like this one, we just bring the 2 to the front. So I get 2x plus 7, and the other one, 2 over 2, simplifies to x plus 1. There we go. So I am going to move this. Wow. Took the 0 along for the ride. Didn't mean to take him. Go back. Go home. Okay. Let's make this smaller. Ooh. Come on. Come on. Come on. Nope. I don't want you. I want you. Yeah. Okay, so make it smaller. There we go. And then I can switch this back to cosine. So I get 2 cosine of x plus 7 times cosine of x plus 1 equals 0. And then I solve. I get 2 cosine of x equals negative 7. Cosine of x equals negative 7/2. Is that possible? Can cosine of x be a number less than negative 1? It can't. So x is an empty set. Let's see for the other side. Cosine of x equals negative 1. Can that happen in any of the quadrants? Of course. That can happen at x equals pi. So our only answer is x equals pi. Check. And last one, 25. Product to sum. Oh boy. So we have sine of something minus sine of something. So the one we will use is this one. So we get 2 cosine of whatever the angle is, theta, plus whatever the angle is, 3 theta, all over 2, times, we're going to product now, sine of whatever the first angle, minus the next angle, there we go, equals 0. So let's simplify this, 2 cosine of 4 theta over 2, times sine of negative 2 theta over 2, obviously those simplify to 2 cosine of 2 theta times sine of negative theta. Okay, we can do this. We can simplify right away. And since it's multiplication, we can actually just solve right now for 0. Since sine is theta here, negative theta, we can substitute it in for sine of theta, and we know it's going to be this. So sine of negative theta equals negative sine of theta. So this is going to be negative 2 cosine 2 theta times sine of theta equals 0. Just brought the negative 1 to the outside. All right, so we get negative 2 cosine 2 theta times sine of theta equals 0. Solve for each. Cosine of 2 theta equals 0, since 0 divided by negative 2 is still 0. And now we can't use 2 theta. We got to switch it back to a form we love, which is any one we want. So I'm going to choose this one. Minus 1 equals 0. 2 cosine squared equals 1. Cosine squared equals 1/2. Theta, in this case, oops, forgot my theta's here. Theta equals plus or minus 1 over square root of 2, which is going to be simplified to 2, square root of 2 over 2. 1 square root of 1 over square root of 2 equals 1 over square root of 2, which equals square root of 2 over 2. It's going to be plus or minus. So other side, sine of theta equals 0. So theta equals 0 or pi, since we're in the first or second quadrant. And it wouldn't matter anyways, that'd be our only ones. So for this one, it would be 0 equals pi over 4. Ooh, that's a 4. And 3 pi over 4. There we go. We have 4 solutions. 0, pi over 4, pi, 3 pi over 4. And we are done. Goodbye, everybody. If you have questions,